So now we carry on with the topic, and the next topic will be operations on a matrix. Operations on a matrix. So now these topics are actually very important. So the first operation that I consider to be an operation of matrix is transpose. Transpose of a matrix. Okay. So what is a transpose of a matrix? So if I have a matrix, let's say my matrix is A, right, and I have values like 1, 2, 3, 4, 5, 6. Now, a transpose of this matrix A is represented as A with a superscript T, right? A small t is put like above A. So A T is basically, you'll reverse the rows and you'll make the rows columns and columns the rows, right? So what you do here is, now this is a row, right? 1, 2, 3 is a row. Now we change this row to a column. 1, 2, 3. Now we change this row into a column. 4, 5, 6. So this is a transpose of a matrix. So transpose of a matrix is basically changing the rows to columns or columns to rows. Simple. So you can just think it like this, okay? So I'm just making this column as the row now. So 1, 4 will go up. I'm making this column as a row. So 2 and 5 will go here. I'm making this column as a row. So 3, 6 is going here. So I'll give you another example. So I have a matrix B. I have 1, 2, 3, 4 as the matrix B. Now its transpose will be changing the rows to columns or columns to rows, whatever you want. So if I want to change this row into column. So I do 1 and 2. So I just bring this 2 down here. So now I want to change this row into column. So this will be 3, 3, 4. So is this clear? Transpose of a matrix?
Yeah.
So I'll give you one question. Just try to solve it. I'll just give you 2 minutes to solve that question. Okay. So my question is, find the transpose of this matrix. Okay. So this matrix X is given as 1, 2, 3, 2, 3, 1, 0, 4, 7, 0, 4, 7. So I want X transpose.
It's okay.
Okay, I'll write the solution there. You check whether you did it correctly or not. Okay. So the answer is, so I just change this column to row. So 2, 0. Change this column to row 3, 4. Change this column to row 1, 7. So this should be our answer. I answer. So this is the transpose of a matrix. Okay. Now the second operation on a matrix is equality of matrices. Okay. Now if I say matrix A is something like 1, 2, 4, 5, and I say that this is equal to a matrix B, then you should always come to a conclusion that matrix B will be exactly same as matrix A. 1, 4, 2, 5. So if I say some matrix is 1, 4, 2, 5, and that matrix is equal to some matrix B, then by this information you should be clearly confident that matrix B is basically 1, 4, 2, 5. So if I have something like 1 minus 2 minus 4, 6, and is equal to 0, not 0, sorry, is equal to A, B, C and D. So what will be A? What is A?
1.
Yes, A is 1, B is minus 4. So minus 4 will be equal to B, minus 2 will be equal to C, C will be equal to minus 2, and D will be equal to 6, D will be equal to 6. So this is the equality of a matrix. If two matrices are like placed on left hand side and right hand side of an equation, and you're just told to find the variables like this, you just equate these values. So first row first column element will be equal to first row first column element of the second matrix. Then this is first row second column element of first matrix will be equal to first row second column element of second matrix. So you just need to equate it this way, sorry, and you need to find the values. Okay, so this is the equality of matrices. So two matrices will be equal if they have the same number of rows and same number of columns. So you can't say that matrix B, like in this case you can't say matrix B is something like 1 2 3 4 5 6. No, you can't say something like this. B has to be a matrix which looks exactly similar to A, because this value should be equal to this value, this should be equal to this, which is not happening in this case. So this is not the right answer for B. Okay, so equality of matrix. For equality of matrix, you need to verify each element of the matrix, right? First element with the first element of the second matrix, second element with the second element of second matrix, like that you should go on. Okay, so that is equality of matrix. Then we have addition and subtraction. So the last two properties, like operations on matrix, is addition and subtraction. So this is addition and subtraction. So let's say I have a matrix A whose number of row is m, number of row is n. So this is the order of the matrix, right? Let's say this is m1 n1, and I have another matrix B with m2 number of rows and n2 number of columns, right? So now you can add or subtract these two matrices only if m1 equal to m2 and n1 equal to n2. So the property of addition or subtraction or and subtraction can only be possible between two or more matrices if their orders are equal. Orders are same, which basically means number of rows are equal, number of rows are equal, and number of columns are equal. So the property of addition or and subtraction between two matrices or two or more matrices can only be possible if all the matrices have the same order. So if they have the same number of rows and same number of columns, all the matrices in the addition or subtraction problem, only then the addition or subtraction can be possible. Okay, so is that clear? This should be totally clear to you. And how the operation is carried out is very simple as well. So if I have some matrix like 1 2 3 4, and I'm adding this with 2 4 6 8, then basically the addition will be 1 plus 2, 1 plus 2, then 3 plus 6, 3 plus 6, then 2 plus 4, then 4 plus 8. So this will ultimately end up in 3 6 9 12. So this will be the addition of the matrix, right? So now before adding or subtracting any matrix, any number of matrix, you just need to verify that their order is completely the same. So they have the same number of rows and same number of columns. Don't make this mistake. I used to make this mistake when I was in 10. So if I have a matrix A whose order is 2 rows and 3 columns, so 2 by 3, and I have a matrix B which I'm adding or subtracting with matrix B whose order is 3 by 2. Now what I used to do is I used to multiply the order and find this as 6 and this also as 6. Now since the orders are equal after multiplying, so I used to conclude that A and B could be added or subtracted. But no, this thing is not allowed. So you should not multiply these values. It's just 2 by 3. It should be 2 by 3 here as well. It should not be 3 by 2. Okay, 2 by 3 matrix is not equal to 3 by 2 matrix. Okay, so this multiplication sign is not a multiplication sign altogether. It is just a representation of this word by. Okay, so it's 2 by 3, 2 rows by 3 columns, 3 rows by 2 columns. So multiplying these two values is a complete mistake. Don't do that. I used to do this. Don't repeat it. So the two matrices A and B can only be added or subtracted if the number of rows is equal for the first matrix is equal to the number of rows of second matrix, and number of column of first matrix is equal to number of column of the second matrix. So is this clear?
Yeah.
If you have any question till now, just let me know. Any question regarding any topic. Okay, so if you don't have doubts, try to revise all these things. Okay, this is basically it for this chapter. There's only one more topic left called multiplication of matrices. So I'll teach you that in like maybe 2 class later. So next class we'll be doing numericals with respect to all these topics that we studied right now: addition, subtraction, transpose, and all those things. So try to remember all the important facts, right? So when can two matrices be added or subtracted, right? What is a transpose? What is a square matrix? What is a diagonal matrix? What is an identity matrix, right? So try to remember all those things, and tomorrow we'll solve numericals from this topic. So that's it for today. If you have any doubts, just let me know right now.